combining like terms. The first thing we need to do is we need to review some vocabulary from last year that deals with terms and parts of terms that we need to know in order to combine. The first part you will see here is called a variable. A variable is a symbol, usually a letter, used to represent a number. Back in elementary school, the variable could have been a box. 3 plus box equals 5, and in that box you would fill in a 2. That's technically a variable, but once we get into middle school, we start using letters to represent unknown numbers. The second vocabulary review term from last year is a coefficient. A coefficient is a number that is multiplied by a variable. In the case of 3x, 3 times x, the 3 becomes our coefficient. The third vocabulary term is what we call a constant. A constant is just a number on its own. If you have an equation and it has the number 3 in it, that is a constant because it is always a 3. Every time you see it, it is a 3. So what do those parts look like when we put them into an expression? Right here, if I have 5x plus 3, let's label the parts of this expression. The 5 is going to become our coefficient because it is 5 times x. It is multiplying by the variable. The x, of course, is our variable. And the plus 3 is a constant. I'm always going to be adding 3 to whatever the value of 5 times x is. I'm always adding 3. That number did not change, so it is the constant. There's one more vocabulary word that I don't remember if you did last year or not. It may be new to you this year. It is called a term. Terms in an expression are separated by a plus or a minus sign. So if we look at this expression, you can see that I have 1, 2, 3, and 4 terms. I have 4 different terms. I have 5x, 3y, 2n, and a 4. So each of those little pieces that is separated by the plus and minus signs are considered a term. Now, in order to combine like terms, there's a few things that have to happen. The first thing, terms must have the same variable. I cannot combine apples and oranges. If I was trying to put all of them by category, apples and oranges are different things. Same things with terms. Terms that have different variables are different. X's are different than Y's. And sometimes I like to even put names with them. If I have 5 X's, I might say to myself, okay, I have 5 xylophones. If I have 3 Y, I may say to myself, oh, I have 3 yo-yos. I cannot combine xylophones and yo-yos because they are not the same thing. Number 2, terms must also have the same exponent if there is any. So an x cannot be combined with x squared because in the x there is no exponent, but in x squared there is an exponent, a power of 2. Third, constants combine with constants. I can take just plain numbers and combine them together. And then the last thing that's super important is we want to take the sign or the operation in front of the term. So I need to remember those 4 parts when we are combining like terms. Let's do an example together. So my first example is 3n plus 7p plus 5n plus 2p. Now, when I go through and I'm looking for like terms, I like to do one of 2 things. One, you guys know I love to color code, so I'm going to color code my different terms. If you only have a pencil, there's another strategy we can use where we draw shapes. So I'm going to color code and I'm going to draw shapes to show what that would look like. So the first term I see is I have 3n, okay, n, nickels. All right, so I'm going to draw a box around my 3n. There's no sign in front, so I don't need to include it. So here I have 3 nickels. and I go and I look at my other terms. Do I have any more nickels or any more n terms? Yes, right here, 5. So I could say I have 3 nickels, 5 more nickels. And I'm going to take this plus sign in front of it. So now when I look at these two, I have 3 nickels plus 5 nickels. So how many nickels would I have altogether? I would have 8 nickels, or 8 n's. Next, I need to go and look for any other terms. Here I have 7p. I'm going to circle it, and I'm going to take the term with it. Notice I circled these because they're not the same as the squares. P's, maybe they're princesses or pickles. Pickles are not the same thing as nickels. So I have 7 pickles plus 2 more pickles or 2 more princesses, whatever term you want to give the variable p. So 7 p's plus 2 p's is equal to 9 p's, or 9 princesses, or 9 pickles. And that's as much as I can go for a final answer. I cannot combine the variable n with the variable p. So this, my friends, is your final answer. Final answer. We cannot combine the n with the p variables. They are different. Let's do another example. One more. Example number 2. All right, let's do x squared plus 3x minus 2x squared plus 5x squared minus 3. All right, I'm going to start at the front, and I'm going to go look for terms that are similar, that are alike. I'm going to draw a box around x squared. Now I need to look, do I have any more x squared terms? I have one right here, minus 2x squared. And then I have another one right here, plus 5x squared. So to combine those, we have to think back to our integer rules. If I just have x squared, that is the same thing as having 1x squared. Minus 2x squared, I'm going to take away 2 of those x squareds, but then I'm going to add back 5 more. So see how I'm using the coefficients to combine? Remember, that's an invisible one right there. All right, so 1 minus 2 gives me a negative 1, plus 5 gives me a positive 4. So I have 4x squared. Then I need to look at my next terms. All right, here is a positive 3x. Do I have any more just plain old 3x's? Nope, I sure don't. So that's positive 3x, so I'm going to add 3x. And then lastly, I have a negative 3. I've already used squares. I've already used circles. I don't know, maybe I'll do a triangle. So if you don't have all the different colors, you could easily draw shapes to show your similar terms. And since I don't have any other constants to combine that with, I'm just going to bring it down. So my final answer is 4x squared plus 3x minus 3. And we're done. That's as far as I can take it. We're not solving it. We're just combining like terms. There is not an equal sign that tells us we need to solve it. I don't know in this instance what is the value of x, so therefore I cannot solve it. I can only combine the like terms, and I'm done.